All right, hello everyone. I'm going to be talking in English. So I'm going to be talking about Functionary using tools with LLMs. So first I'm going to introduce what are the tools and how do we use it, what are the challenges in using tools, what are the functions that we use in agentic workloads, and I'm going to talk about the results, benchmarks, and the use cases. And if I have time, I'll demo. So when we talk about tool using is basically taking actions, making LLMs take actions based on your instructions, based on your input. You first define a set of capabilities to a model, then the model then decides whether it should just respond to you or execute that function. That function can be anything in terms of capabilities. It could be starting a car, or it could be if it's an assistant, like a physical assistant, physical robot, it could be that robot giving you coffee, bringing you coffee or tea. So there are different systems that we use when we want to develop something that can reach to a certain goal. If we have a goal, let's say we have a goal of researching about some subject, and we could define multiple agents. We could create different agents. Yesterday there was a hackathon, and a lot of people have submitted on there to create multiple agents. And those agents were separate, totally separate. But when we talk about function calling, this is a one single model that is capable of executing all those kind of agentic works on its own. So this already exists in proprietary models. It works totally well in general, but we want open models that are capable of using tools. And why? Because we want privacy, we want extra alignment, that we want the model to behave in a certain way, and of course we want freedom to change our model. So I want to start with a use case, exact use case, where imagine we have a physical robot that we created ourselves, and we want it to do certain actions, such as bringing us a coffee, like I said, or just going to a bathroom. And we're defining those kind of actions with these kind of agentic functions. And then we're expecting it to understand us rather than just responding to us. It needs to do certain actions. It could be wearables too, where you might have a watch or some sort of wearable device that you wear on you that can be a personal assistant for you. Or I gave an AI researcher, so it can Google for you, and it can search for any type of information and bring that information and summarize it and do all of these in an appropriate order rather than randomly going through the websites. And there's Rust track, and you can actually execute any type of Rust function too. If you're a programmer, it could be any type of function with certain parameters that you want it. And of course, you can automate the mobile devices. You can make them click on certain things. So this is a generic stack that we have when we develop agentic workloads. And at the base level, we have the hardware CUDA or CPUs, and on top of it, we have the foundation models. And we have the lower level inference systems. And on top of it, we're there at this point, which is Agentic System API, where we build on top of the model toolchain API. right below the agentic apps. So if you have developed agentic apps previously, you may have realized that it may assume things wrong. Like it may think that about certain knowledge, but it is not true, completely wrong. Or it could make up things, which we call it hallucinations. For example, you might define a weather function, you might define an agent that can fetch the weather for you, but if you ask it, this is so funny, like, if you ask, what is the weather right now, without giving you a location, it will just assume it's in New York for some reason. A lot of models are just assuming, oh, you're in New York for some reason. So this is a hallucination. Those are the problems that exist even today in a lot of small models and open models. And it could make type errors, such as instead of integers, it could use floats. And dependency errors it can make too. So, for example, if you have a pipeline where some step relies on the previous step, or step X, it may not know this kind of dependency, so it might just execute this. If we go back to our assistant, there might be steps such as like go to the kitchen and make the coffee and bring it back. Those are the steps. And it might just say, make the coffee before going to the kitchen, which is not what we want. So there are lots of models, open models right now. When Functionary when I first developed the Functionary, it was basically there was no open model that are capable. But currently we have Llama 3.1, Qwen 2.5, DeepSeek XLAM, Code GX. Kinkai just talked about this, FireFunction and Gorilla. I'm introducing Functionary, which is MIT licensed, completely open source project, a large language model that is capable of execution of the tools. And we open source the training code, inference, and all the weights. And it is capable of executing those kind of steps in parallel, in one shot, like in one single inference request, or it could do sequential, one by one, if it depends on the previous ones. Obviously, it is conversation capable. I'm telling you this because a lot of tool-using models, agentic models, only can execute functions, but not answering you properly. And we do have code interpretation support too. So this is an example tool definition. And we're starting, this is searching for a flight. We define the description. We're saying, OK, this is going to be used for searching for the flights. And we have some required parameters. These are essential origin, destination, and departure date. Otherwise, it should not return anything at all. But maybe you don't need the return date. So if you don't give the origin, the model should ask you, oh, where you want to go, or what is the target for your flight. But it might not ask, what is your departure date? What is your return date? Because it's optional. So this is technical diagram. I'm not going to get too much into this because it's very technical, but we are converting our schemas, our tool definitions, into TypeScript schemas because it's much easier to understand for the model, and TypeScript definitions are much simpler. So we convert it into available functions, and we might or might not put some system message about it. And this is our query here, what's the weather like in Hanoi? And with all of that definition, we put it into our model, our neural network model, and then the model can say, get the weather in location Hanoi. And after we get the response from the tool, it can interpret and say, oh, it's 10 degrees Celsius. Another example here, we have getRide function redefined, and user might ask, I'd like a cab, but it should ask, says, okay, I can help you with that, but could you give me, where's the destination for the taxi? So, yes, I'm gonna skip. And our functional model, this is SGD dataset made by Google, and our model is the top performing model among these models that I'm showing you. But this is a tool sandbox made by Apple, and our model is right behind Opus and GPT-4o. So this is made by Berkeley. This is a very recent one. It's not published still, but this is the high-performing state-of-the-art model that is focused for function calling right now. So for the safety, we could restrict the model's capabilities, and we could prevent it from unauthorized and potentially dangerous actions. So it will not be a huge problem. If we validate all the inputs and outputs, it should be also totally fine. If you have heard of Llama Guard 3, this is a moderation model. If you put your prompt into Llama Guard 3, it will flag it if it's suspicious problem. So I'm moving fast, but yeah. In the future, I envision where the LLMs are going to make their own decisions rather than us giving every single step, saying that, oh, do this and that and that and that. That is very problematic because you want a helper, you want the assistant to help you rather than just giving you every single thing, because it would otherwise be very cumbersome. And I see that they're going to be fully integrated into physical embodied devices. So there was a robot on the whole. So if we put this type of model that is capable of taking actions, it will physically move and take the action rather than just digitally having those assistants. And currently, there are only a couple of models that is capable of taking vision and outputting some sort of action. For example, you might put it on a security camera, and if you see a fire, then alert me, or call the police, call the ambulance, or something like that. If you put something like that, if you develop something like that, then those types of models can take actions too. This is the future that will happen, that is happening. It's open source. You could, if you're a developer, you can set up with one single command and start with one single command. This is on GitHub, and it's open, and it's fully OpenAI compatible. So you could just replace the URL and model, and then use just like regularly. We had different models. We started with 2000K context. This was like more than a year ago. It was Llama 1, and it went up to 4K context with Llama 2, and then we went up to 8K with Mistral. We went up to 120K context currently, which allows very, very complex and long agentic functions to work properly. So it's in these addresses, GitHub and Hugging Face addresses. All right, so I'm going to show a quick demo. Yes, sir. So I have defined a certain set of tools here. We have the getWeather function, and we have a countSale function, the model will decide. And we also have code interpreter that it can execute certain code if it's necessary. And so I'm just going to copy paste this because I can't write Chinese. Okay. All right, so it first decided, okay, I need to get the location, get the date first, and it used Python because it knew that it can get the date with Python tool. This is running in gvisor sandbox environment in another server, and it got the date, exact date. Now it knows what is the date, what is the current time. And after it knows the current time, now it's making another decision. The decision is to now call the getWeather function. So as you can see, this function call relies on the previous call. So it needs to determine which are the dependencies. And then after we got the results, 16 degrees and 18 degrees, and it has some interpretation here it made. And it could just answer regular questions right after or before. I'm telling you this because this looks very simple, but a lot of models are having problems with this, especially because when they're training with function calling, they're forgetting these types of, like, catastrophic forgetting happens, and the models are forgetting how to communicate. And I'm going to ask something that is also complex. I don't know if you can see it at the bottom, but so I'm asking, please get a random date in 2023 and get the weather of Los Angeles for it. So it's writing a code to get a random date. Okay, it got a random date. It's 0520. And then now it gets the weather for the Los Angeles for that date. Yep. I mean, I could go more, but that's basically it. If you have any questions, I could answer.